in this case, we need to work out effectively the coefficient, the value of x in this question for next to H2O in the hydrated sample of MgSO₄, right? And we've been given some masses. We've been given the mass of the hydrated sample, the mass of the anhydrous sample. So let's go ahead and try and figure out what this would be. Now, if you want to figure out the value of x, what we want to be able to do is compare, well, what's the number of moles of the H2O, what's the number of moles of MgSO₄, right? And given the data that we've been given are primarily masses, we would need to effectively use the equation that the number of moles n is equal to, and this is rearranged so that the number of moles n is equal to the mass divided by the molar mass mR, right? For MgSO₄, we've been given the mass in the question. For H2O, we haven't been directly given the mass, but we've been given the mass of the hydrated sample and the mass of the anhydrous sample. Simple arithmetic will give us the value of the H2O mass specifically. Now, for the MgSO₄, right, you can see the mass here is 6.77 grams, and we need to get the molar mass to really be able to do something with this, right? So if I say the number of moles for MgSO₄, right, is going to be equal to the mass m 6.77, and then we need to divide it by the molar mass. So let's work out what the molar mass is going to be there. So we're going to use the periodic table to work that out, right? So that's effectively MgSO, right? So for convenience, I've also got them here, but that's effectively going to be 24.3, right, plus 32.1, right? So MgS, and then 04, so that's going to be 16 times 4, right? So if you do have a go at working that out, you should find that you get 120.4, right? And that's going to be in grams per mole. Okay. So therefore, what we're going to have here is 120.4, right? And if you do have a go at working out what that is, you should find that you get 0.5, no, not 0.5, 0.05 6229, right? And that's effectively in moles, and it's to 5 significant figures. 5 significant figures. Okay. Okay, so that's the MgSO₄ aspect of things. Now, as I said, for the H2O aspect of things, you do need to do a bit of arithmetic. So we're going to need to do effectively 11.09. So this is for the mass of the mass m of H2O is going to be equal to 11.09 minus 6.77. Okay, and so if you do work that out, you're going to get 4.32 grams. Okay. Now, what we can say on the basis of that is that the number of moles of the H2O is going to be equal to 4.32 divided by, and well, we need to figure out what that value is, right? And this is divided by the molar mass of H2O. So you may already know what the molar mass of H2O is, but you know, you can use the periodic table. So H2O, so that's going to be effectively 1 times 2 plus, and then for the oxygen component it's going to be 16, right? And of course that's going to give us 18, right? And that's going to be in grams per mole. So that's the molar mass of the H2O, right? So therefore the number of moles for the H2O is simply going to be 4.32 divided by the molar mass, so that's going to be 18 divided by 18. And yeah, so if you do work that out, you should find that you get 0.24, right? So it's, yeah, that's the value you get, and that's going to be in moles, right? Okay, so we've got these two values, and if you remember, what we've got is MgSO₄ dot, and then we've got the X and then the H2O. So what I'm going to do, just for clarity purposes, is I'm going to put the put together a molar ratio, and I'm going to make sure that the MgSO₄ aspect is on the left hand side. Okay, so it's effectively, I'm going to say the number of moles of MgSO₄, MgSO₄, as a ratio compared to the number of moles of H2O, right? And yeah, so that's going to be a ratio, so it's going to be 0.056229 is a ratio of 0.24, right? And the coefficient with regards to MgSO₄, as you can see here, is effectively 1, right? I mean, it doesn't have a number next to it, but we can infer that the absence implies the coefficient is 1. So what we want to do to work out what the H2O, the coefficient for the H2O, the value of X effectively, we want to get this value on the left hand side to be 1. And how do we do that? Well, the way to do that is, of course, to divide this value by itself. So if we divide it by 0.056229, we're going to be able to get 1 on this side. And given it's a ratio, what we do on the one side, we need to do on the other side. So we also need to divide 0.24 by the same. So divide that by 0.056229, okay? And once we've done that, what are we going to get? Well, on this side, of course, we're going to get a 1, right? But then if you have a go at calculating that and see what you get, you should find that you get 4.2683, right? And that's to 5 significant figures. All right, and the coefficient in this case, it does need to be an integer value. And so what we're effectively going to do here is simply round this value. So we're going to round it, and in this case we need to round it down, right? Because it's a 426, right? So round it down to 4. So it's going to effectively be so if we round it, effectively it's going to be 1, 2, 4, okay? And on that basis, we can say that the value of X is 4, right? So that effectively gives us MgSO₄ dot 4 H2O, right? So here we can say that, well, the value of X in this particular question is, let me use a color that's more visible, is going to be 4, okay?